You're about to listen to the Complete Developer Podcast, the podcast by coders, for coders, about all aspects of life as a developer.
I'm Will, the curmudgeonly experienced developer.
And I'm Beej, the optimistic newbie developer. Let's talk about text, baby. Let's talk about you and strings. Welcome to another episode of Complete Developer Podcast. This week, we're talking about text and strings. We'll discuss the deep, dark realm of bits and bytes used in word formation, ASCII characters, and encoding. The episode will close out talking about string manipulation, operations, and some security issues.
Yeah, we're not actually getting as deep as I got. Because that rabbit hole has no end. It's like looking at alien videos on YouTube. Like, you'll be there 5 or 6 hours from now and still looking at weird stuff. But I got it as trimmed down as I could.
All right.
Let's put it that way.
So before we get started, Will, what have you been fighting this week?
I am in the process of setting up a CI server at work. I know a few weeks ago, the server got in. Actually, it may have been last week. It kind of all bleeds together. Got it installed in the rack, kind of jacked up my back a little bit doing that. It's just a weird angle, like screwing stuff in and having to do marginal acrobatics to get it in there.
That was last week. You told me about it.
That was last week. It seems like it's been longer. So I've got to get, Subversion and TeamCity, and then I've got to start working on our, builds and go through all that fun and games. I've got that. I've got the actual project that I'm working on, and then I've got to work on getting us into a messaging-based infrastructure, and I have all those at the same time. So obviously, I'm a little bit stretched at the moment, but we're good. It's fun because now I can actually take a workflow that's not been terribly efficient, and I can make it more efficient. And He Who Shall Not Be Named is pushing an initiative right now to get us all to use LeanKit for Kanban boards. Because you came in and helped the sales team do the sales pipeline that way.
Yeah.
But because of that gave us leverage that we then used to get that for the dev team. So we went completely backward the way of everybody else doing that.
That's so funny because...
That's why we did it on purpose.
He wasn't even in the meeting.
No, he wasn't.
It's just funny that he's the one pushing it and he wasn't there.
Well, he's the one leading it.
Okay.
We've both been pushing it.
Yeah. All right.
And anybody that knows us knows that we push everything.
Ain't no pulling around here.
Yeah, it's like we kind of do a lot. We're getting more and more autonomy, and we're delivering results, and so they keep giving us more autonomy. So it's pretty good. It's a lot of stress, a lot of things. Trying to figure out, is this going to burn us? And there's a lot of big picture stuff, and you don't always know what's going to happen. But yeah, it's good. I'm doing good. So how about you?
Well, I've been fighting in Hibernate link queries and trying to search a nested list to match an item on another nested list. It's all sorts of inception at work right now.
Yeah. Can I suggest something? Make a view. Does it and query that?
Yeah, we kind of...
Put some of that on the database server because I've done this before and it's not going to get better.
Well, we found a solution. It was funny because I asked my boss for advice, and a couple hours after pair programming and working together on it, he looked at me and said, "No, that's a good problem. I don't think we've solved it yet." It took a couple of days. Another one that's been kind of driving me crazy is an issue with IIS.
Oh, the cores stuff that you sent me the other day?
Yes. Oh, my goodness. It's been...
Were you not able to alter your web config to do that? What about you might have to do that to machine config.
Yeah, well, let me get into it. I'll tell you all about it. So I've been attempting to help out the front end this past week, and I've been stopped by a couple of different things so far, but completely got stopped dead by an inability to access the API because of a cores issue. And I can access it when I run the application layer on a local IIS Express server.
Yeah, never trust IIS Express.
Yeah. Well, I can access it when I'm running it local.
Yeah.
All like that. But when I try to use or test the actual API from the server, it's telling me that there's no access control allow origin header when there clearly is, because I wrote it, and it works in Postman. So when I'm in
you're actually
Postman,
seeing that in Postman coming down?
Yes, I am. I mean, I worked on it for a few hours. We record on Monday, so I worked on it for a few hours on Friday, and then got my boss in on it. And after 2 days, neither of us could get it working. Finally, I was talking to our front end lead, and he was asking me about my progress on the work I was supposed to be doing for the front end. And I told him about the issue. Turns out no one can get it running through localhost. Like, we have to actually post to the server.
You have to have the website out somewhere and then post it, because it can't do the cross-origin stuff because localhost is anybody.
Yes.
That actually makes more sense in a very terrible sort of way.
Yeah.
I'm sorry.
Yeah. That's what I've been dealing with the last few days. And so, but once he told me how everyone else had worked around it, if he hadn't been feeling ill and gone home early last week, this wouldn't have been an issue. Because,
you set up your own custom host name locally and then did the thing.
Yes.
I didn't think to tell you that. I could have told you that. It just never occurred to me. So yeah, I guess it's about time to roll the music.
This week for IoTs, I have sort of a story. My sister sent this to me, and it's a little bit of IoT in the news. The NFL is going to be placing computer chips into some of the footballs for select games in the 2016 season.
So do they, these chips, are they capable of running gzip?
Maybe. I don't know.
Because I'm wondering how the deflate command works.
But she told me that she did a double take on seeing the article, thinking that they were going to be putting chocolate chips on the footballs, which is a completely different article. In an effort to be even more precise and completely remove the refs from the game, the NFL is replacing them with data chips and IT departments to interpret the data. Seriously, though, they are looking at trying to get some IoT data collection in conjunction with referees at games to add more accuracy to ball placement and calls. And I'll include a link to the article. It's actually really interesting if, like me, you're an IoT geek. So who's talking to us this week?
Well, it's not a review, but it's a shout out to developerpodcast.com and a thank you for adding us to your site of awesome podcasts, which I didn't realize there were that many. Mm-hmm. I've got it up on my screen. Like, when we get done here, I'm taking my phone in there and figuring out what other podcasts I want to listen to. It was not in my mind that there were that many.
I would say probably 2/3, if not more, I already listened to.
Yeah.
And that's why I was so excited when we got added to the list, because like, it's so awesome to be included.
To see our ugly mugs at the top of the website. Yeah. Let's be honest here.
Yeah, it's true. But I mean, we're included with the likes of .NET Rocks, MS Dev Show, and Coding Blocks.
Yeah,
just to
especially
name a few.
.NET Rocks. Like, being in the same cohort with them on anything is phenomenal in my book. So from the Twitter feed, I've added Complete Dev Pod to http://developerpodcast.com. My growing collection of podcasts for software engineers. And if you contact us on social media and you like a CDP swag bag, leave us a review in iTunes or comment on the website or any of our social media. And, we post everything to Facebook, Twitter, LinkedIn, Google+. Yeah. I feel like I missed one somewhere, but I don't think I did. No, it always seems like there's one more. But
no, we haven't gotten on Instagram yet. I'm still working on figuring out how.
Yeah, we don't really have faces for Instagram.
And we have faces for radio.
Yeah, we have faces for SoundCloud.
Yeah. That's so true. All right, so getting into the episode, Will put this together and did a lot deeper research than we're going to talk about.
I went down the rat hole on this stuff. Now, you bear in mind, I have been doing software development professionally full-time since 2003. Went to school for it, played around with development, like all the way back to GW Basic and Axis. I can't remember which one I did first, actually, but like back in the early 90s.
Yeah.
And so strings have always been there.
And they always will.
Yeah, it's a basic data type. Like, it's one of the first things we did with computers, right? As soon as we got them to process numbers, we said, hey, can we get them to process text? Because that's the next thing we need.
So what is a string?
Well, it's, the dumbest definition, of course, is that it is a data type that stores text.
All right. What's the second dumbest?
That would be the Wikipedia definition. Because, always second dumbest. No, this is actually a pretty good, solid article that completely obliterated my free time for a bit. And their definition is, in computer programming, a string is traditionally a sequence of characters, either as a literal constant or some kind of variable. The latter may allow its elements to be mutated and the length changed, or it may be fixed after creation. Then there's always some kind of programming thing there too, as far as like it's fixed, but it could be mutated later, like .NET does. Not really. It's not that it's mutated. You make a copy and you mutate that. A string is generally understood as a data type and is often implemented as an array of bytes or words. And that's words as in byte data, not words as in text, not spoken words. That stores a sequence of elements, typically characters, using some character encoding. So the reason we've decided to do this is that strings are a lot more complicated than you would think. And it just keeps getting worse. Like the thing I looked at today made it much worse in my mind, and it was already terrible enough to decide I needed to do this. Yeah, it's very complicated. So I wanted to start out with some definitions of terms so that you can actually understand what I'm talking about. Because going, hey, this is a chunk of text, that's not really descriptive at the computer science level to understand what's going on.
Well, we're pedantic nerds, so we like to get very descriptive.
Yeah, and it can get, it can come up on you really fast if you don't have these things down.
Makes sense.
So the first thing is what is a character?
Well, a character is a minimal unit of text that has semantic value.
Right.
According to Wikipedia.
Right. The Oracle of Wikipedia says that. Right. So it's a individual piece of a string that's, by itself. The next thing is a character set. And a character set is a collection of characters that might be used by multiple languages. For instance, most of the English alphabet overlaps with the Spanish alphabet. Right. So those character sets overlap, but English is this set. Spanish is this other set, and they mostly overlap. A coded character set is a character set in which each character corresponds to a unique number. So the idea is, for instance, in ASCII, I might say that, I would say in ASCII, a capital letter A is 41 hexadecimal. That's 65 decimal. And you understand that I know this because I have been hit by it.
Have you read The Martian?
No.
Well, I'm re-listening, I should say, to it currently. I'll probably be listening to it on the drive home. And in it, the early form of communication that he had, like one of the earliest forms of communication he had with Earth, was a hex system.
Yes. Well, hex is short for binary. Like it's a shorthand that is useful for saying a binary number in a compact manner. So yeah, a coded character set basically says, hey, I'm going to map this character to this number. When you see this number, it means this character. A code point of a coded character set is any legal value in that character set. And this comes off of Wikipedia, so they're explaining, it's a 32-bit integer data type where the upper 11 bits are 0. That would be the first bits. This is going to get a little bit more interesting later. Next thing is a code unit. And a code unit is a bit sequence used to encode each character of a repertoire within a given encoding form. You see this keeps getting a little bit worse. A character repertoire, which is what we used in the last definition, and I did badly on the outline by not introducing that first, is the full set of abstract characters that a system supports. Some systems are open, so you can actually extend them.
Wait, what's an abstract character?
That's a minimal unit of text that has semantic value. Some are open, some aren't.
That was a character. Like, what's the difference between a character and an abstract character?
Can't tell you.
Okay.
I don't know that there's necessarily a difference. Okay, so a few other definitions that are kind of basic computer science stuff, but we haven't touched on them, is what is a byte?
8 bits.
Right. It's 8 bits. It represents a chunk of data. So it could be 8 bits unsigned, which makes it 0 to 255 in value, or it could be 8 bits signed, which makes it, was it negative minus 127 to 127?
Mm-hmm. Yes.
But you don't know at that point, right? It's just, here's a chunk of data. The next thing is a word, which is typically understood to be 2 bytes.
So 16 bits.
Right. However, there's also the double word, which sometimes gets called a 32-bit word, which is
4 bytes.
Right, 4 bytes. Now, just to throw this out there, a half byte is called a nibble because somebody thought they would be funny.
See, when I see nibble, I think of QBasic and the snake game called Nibbles.
Yeah. I mean, I totally get it. So, like, there's your set of definitions. Now, this is where things get interesting because, okay, let's say I have a sequence of characters. How do I know what's in there? This is your core problem with strings is how am I representing this? Because it's not text when it's stored. It's a sequence of bits.
Mm-hmm. Ones and zeros.
Yeah. So you have a bunch of different types of encoding. ASCII, for instance, is a 7-bit. So the leading bit is basically a switch that tells you, hey, do this ASCII and then otherwise do this other thing.
Okay, gotcha.
They just picked, hey, what will work with English, and they went on with life. And that worked okay for a while until it didn't, and then when it didn't, it really didn't.
Well, yeah, that's what most things are.
In the 90s and the early 2000s were an absolute firestorm of encoding problems as a result of this. The next one is EBCDIC, and this is the really old scheme that you'll still see on mainframes. You'll see it in a lot of data imports, and that is an 8-bit system. I wrote a converter from EBCDIC to ASCII, back in college. It's just a different numeric representation for the characters, and they have different control characters and different things. So it's not a one-to-one mapping. So like if you mapped from EBCDIC to ASCII and then you mapped back from ASCII to EBCDIC, you'd lose data.
Yeah, I can see that.
The next one is Unicode, and this is what you'll mostly be dealing with coming into development now. And it's got a bunch of different code sizes. UTF-8 is the most common, but I've seen all the way up to UTF-32.
I've seen that. I've not actually seen it in practice. I've just seen the existence of it.
Yeah. What's interesting is like the UTF-32 is backward compatible with ASCII. I've seen it backward compatible with EBCDIC.
32?
Yes. We had a data import at work that happened on. And we envisioned whoever came up with this idea as somebody that mixes toothpaste with orange juice and then drinks it, because I don't know why you mix those things together. But that was the thought pattern. So Unicode, like your basic one is UTF-8. And on that, your code points map to a sequence of 1 to 4 code units. It's backward compatible with ASCII, but what it will do is it will actually look at that leading byte and go, how many bytes do I need for this character? Which is a really strange setup. UTF-16 kind of does the same thing as well, but it's a word size. So it will do, if a code point can be encoded in 1 unit, it is, otherwise it goes to 2, because that's the way that works. And they refer to this as Unicode surrogate pairs. And then you get to UTF-32, and every single code point gets a single code unit because, hey, we have a giant address space. Does that make sense so far?
It makes perfect sense.
And then there's others, there's ISO 2022, there's Shift JIS, there's tons of different actual encodings of text. A lot of them are based off of how you have to process the text, how you have to store it, or a lot of them, frankly, are just legacy from the hardware that they're sitting on. So encoding is one thing that will trip you up on strings. The next thing is Indianness. And this is Indian with an E. It starts with an E, not with an I. And let's get into the etymology of this first, because this will kind of explain the whole thing.
Okay, because I've not heard of this word.
Do you remember Gulliver's Travels?
Yes.
Do you remember the scene where a civil war erupts over whether the big end or the small end of a soft-boiled egg is the proper end to crack open?
Yes.
That's where this comes from. Because somebody was a bigger nerd than me. And this is the way they came up with it. Essentially, according to Wikipedia, let's give their definition. Indianness refers to the order of the bytes comprising a digital word to computer memory. So you say, okay, I want to look at the high order byte and say, what's in here to determine what I need to read and how I'm going to interpret the rest. Right?
Okay.
Which is the high order byte? Is it the first one or the second one in a word?
Mm-hmm.
Well, it depends on what system you're on, because some systems do it different.
Of course they do.
Right, because I mean this goes way back. So big Indian, is where the most significant byte, that's the one with the most significant bit, is stored first. Little Indian
in the cupboard.
Little Indian, the most significant byte is stored last. So if it's Little Indian, you get the stream and then you get how you read that data. Whereas the other way around, you get how you read it and then you get the stream.
Okay.
It's two different ways of looking at the same data, but you got to know which one you got. Otherwise, you're going to be dumping junk text.
That makes sense, and I'm guessing there was like a big argument over this at some point.
It wasn't. Yeah, there was an argument, but there was actually two platforms that evolved separately, or more than two, really. Intel 86 processor systems tend to use Little Indian. Internet protocols use Big Indian. Do you see the problem?
Yes.
And they also call that network byte order. And there's some sort of digital signal processing reason why they do that. It's an optimization for sending data over. I have no idea. There's probably somebody that will call in and tell us, or actually they'll write in and tell us because they're not calling us. But so there's that, and you have to be able to convert from one to the other, right? Because if I have a string that's Little Indian, I need to convert it to Big Indian before I pitch it over the wire.
Yeah,
if I'm doing low level enough. There's also another one called Mixed Indian, which is where the ordering of the 16-bit words may differ from the ordering of 32-bit words because there's not enough pain in the world. You typically will not be dealing with the Indianness of a string unless you're doing lower level stuff. Like if you're doing C or you're doing Delphi or something like that, then yes, this is something you think about. C++ probably. You don't do that in .NET. You don't do it in Node. There's libraries to help you do this. Actually, there's libraries pretty well all the way down.
Yeah.
This is not stuff
there'd be libraries in C++ for this.
Yeah. This isn't stuff you want to screw around with if you can avoid it.
Yeah.
But it's important to know how it works. The next thing is, if I have a stream of characters, right, that's either, it doesn't matter how it's encoded, how do I know the size of the stream? C strings are terminated with a null on the end. So it's like, hey, here's the pointer to the data, read until you get a null, there's your string, right? Because they're low level and that's the way they do it.
But C isn't C the programming language?
Yes.
Okay.
Pascal strings, on the other hand, go, hey, here's the pointer and here's the length. Go to this length and get the data.
I remember that from learning Pascal.
Right. So, and again, this is abstracted. Most libraries, if you're doing higher level languages, you don't have to deal with this.
Yeah,
but if you're, say, talking to Delphi DLLs and C DLLs in C#, you better know because you're not going to get the results you want. It'll truncate things. It'll do weird stuff. And there's some things that we'll talk about here in a minute that's why this is important. So representation is another thing. Now, the next thing is what I call other nastiness. And these are things that you have to think about when you're processing strings because the strings have semantic meaning, right? Like they're not all displayed on screens. They're processed. You do something with it. Like, hey, it's an address. Well, mail gets sent somewhere. So you're going to have to do something with that. You may want to, I don't know, for instance, make it uppercase. Yeah. You're also going to process that address. You're going to put a barcode on something.
You may want to make it camel case.
Yeah, well, casing is interesting. Yeah. English casing is not so bad. However, some letters only exist in one case. For instance, in German, the Eset character, which is the B, that's like the double S, that's lowercase only. And it's only used after short vowels and diphthongs. While SS is what's written after short vowels. The same, like the casing matters depending on where it is. And there's, especially with your Northern Germanic languages, this is a thing. The character it's only uppercase or it's only lowercase. And there is no casing, but the other characters in there can be cased. So you got to know that difference. And see, in Epsidic, you could say, okay, I'm going to add this offset to this character, and it will now be uppercase, or I'm going to take this away, and it'll be lowercase. Because it was a nice shorthand. You can't do that with Unicode. Because what language is it? Well, it may matter a lot. And the words are not necessarily, byte to byte. It's like, okay, I got to look at this and go, what is this? And then take that and put it in a table and figure it out. Mm-hmm. So casing gets nasty. Just the stupid act of going, here's a lowercase a and I want it to be an uppercase A. Well, because this string could contain German, I can't do that simply. Now,
that makes sense.
And it gets even better. Diacritical marks is the next thing, especially when you get to internationalization. Although, oddly enough, this still happens in English. You just don't see it as much.
Just for those of you guys that aren't as nerdy as us, diacritics are glyphs added to a letter that change the sound of the letter.
Right.
Think about the 2 dots in the I over the word naive.
Yes. Or the little tick mark after the E in resume.
Yeah.
Because it's not resume. Like how you know which one it is that diacritical mark. It changes the sound. It doesn't change the spelling. So that's an interesting case because you don't want to lose that data. So when you're translating things back and forth.
Well, no, that data can be very critical because you and I both went to, we both had Hebrew.
Yeah.
In our school or in our college, and those are what indicate the vowels in Hebrew.
Yes.
And several other languages. Yeah. So there's other languages too. I just remember Hebrew because we learned Hebrew in
I can still recite like the first couple of the first couple of verses of Genesis in Hebrew. Now, the other thing you get is tonality. So if you're doing pinyin or some of the, that's a representation of Chinese, tonality plays a bigger part. Like if you go up at the end of the word versus go down, it means 2 completely different things. And if you don't want to insult somebody's mother, you have to get this right.
As opposed to English, where if you go up at the end of the word,
it's a question. And you are clearly hosting an NPR show.
Yes.
Because that's how they say every statement they say.
Well, that's how I know they're done talking, like they're done with that statement.
Yeah.
Because they may say several sentences in a row, but they end the statement with a question.
Up. Yeah. And because that's the way it is in English, right? But we don't mark that.
Yeah.
In other languages, that can be really, really critical. And the reason this makes a difference is character encodings and way of representing characters has to be fairly compact because of the amount of text going back and forth. And it still does, but especially when this was envisioned, it really, really had to be. Because, this is like 1980s type stuff. And so diacritical marks will get you on this. And you have to write code that's aware of those things if you're going to actually process a string well. So like every introductory C and C++ class, it's like, oh yeah, here, write a class that does a string. Right? You'll have to do that. You're not writing a string. You're doing a byte array that looks like a string. That's not the same thing because of the level of complexity here is just very deep. Now, it gets even better, as usual. The next thing is ligatures. And if you watch True Crime TV, you'll understand a ligature mark. Typically, if that's brought up, somebody was strangled, right? It's a thing that binds.
Yeah.
Like a noose on the neck. Ligatures are something that you don't really see a lot in English, but you'll see on occasion. There's like an AE sound. Or that's
like the word aesthetic.
Yeah, some spellings of that, where they jam the letters together. Mm-hmm. That's a ligature.
Okay.
And so you got to have a character code to represent that.
You see it more in British English,
right,
than American English.
Yeah, because we're just like, we're done with it, right? In our case, the ligature became 2 characters. However, ligatures can also go the other way. Ampersand is an example of this. It started out as a ligature and became a character. So if you're doing something from, Roman times, it's a ligature. And if you're doing it from American times, it's a character. And you got to know which one you're dealing with. And so you have to have a means of encoding these. And there's a lot of really deep, nasty stuff here. Like I'm kind of glossing over this because this was the stuff where I just kept going, holy crap, this is awful. Like I wish I'd never, it's like opening a door to a cellar that you knew was never there. It's like you just wish that you never opened it.
Yeah.
Yeah, that's what this kind of stuff is.
Well, I mean, and a lot of this, for those of us higher level programmers, we don't ever have to think about this.
Mostly.
I said a lot of it.
Yeah.
It's good. It's good, like you said, it's good to have a basic understanding of it, because it'll make what we do in the higher level languages better by understanding how they work.
Yeah, and if you have errors that come out,
yeah,
this will help you see it too. Like if the AE gets broken out and it's not supposed to be, okay, I have a problem with ligatures. You don't know where that is, more than likely, but you have the verbs where you can get it into Google.
Yes, and that brings me to another point. We do have an upcoming episode on using Google properly and how to do that, because there's stuff that you don't want to get into. Like, you don't want to know this stuff, right? You want to look it up. If it's not your day-to-day, you don't want to sit here and study this because it's painful. And there's really a lot more in how Unicode represents text that I did not get into for very good reason. Partially because if I wrote it in the outline, I'm not sure that I could actually remember it well enough to put it, to speak this into a microphone. Yeah.
Even with it right in front of me. Like, I don't know that it would pass through.
Mm-hmm.
So that's our category of other nastiness. Okay, this sets the tone for what you do with strings. Now, think about this whole set of nastiness and how things are encoded, how things are moved around, the Indianness and all that kind of stuff. And start thinking about the operations you do on a string. Because now why this is painful will come into very clear focus. Okay, the easiest sample is concatenation. Well, it's not the easiest, but it's the first one on my list.
That's where you bring two strings and make them into one.
You stick them together.
Yeah.
Well, what happens if they aren't encoded the same? You have a type conversion issue, but you're using the same type. So you're going to get it wrong. What happens if one of them is terminated with a null, and you say, okay, these are just both byte arrays, and I'm going to stick them together? Well, you just truncated the other one off. You see the problem?
Yeah.
And same thing with encoding levels, because, I shoved these two strings together.
This is where you need another layer of programming just to deal with the differences within the type string.
Yes. The string is not a string. That's like saying, it's a number.
Yeah.
What's a number? Well, is it an integer? Is it a real? Is it irrational? Is it
a float? Is it a double?
Is it imaginary?
Yeah.
It's like that's not a thing. It's a category of things, and that's what a string is. And we mostly hide that away well enough where we don't get hit by it until we do get hit by it.
And then you're totally lost. And that's what this episode is all about is, hey, this is to help you not be totally lost when you do get hit by it.
Yeah. So you know what's going on.
Yeah.
The next thing is splitting a string, right? So it's like, okay, I'm going to break on a delimiter. Okay, well, how do I do that? Well, if I'm treating a string as a byte array, and I say, hey, I want to look for a, let's see, let's break it at the word level, right? All right, so it's ASCII character 30, which is a space. That's 20 hexadecimal. You can tell I know too much of this off the top of my head. I'm going to break on a space in a byte array, not in a string, but in a byte array, and I'm going to do a naive implementation. What happens? Well, at some point, I come across a 16-bit, a 32-bit word in there, a chunk of text that's supposed to represent a character, but because I'm not aware of that, because I'm not reading the encoding properly, I break on the wrong part. I've now changed the meaning of that string. It gets even better, because if, let's say that, I don't know, I have a web server that's taking data in.
See, I'm thinking about this, and I'm thinking, you've had a lot of issues with the wraparound. I was just thinking about where
on Visual Studio Code. That's where we keep our notes.
Yeah, on Visual Studio Code, he's had a lot of trouble with the wraparound. But I was just thinking,
how does it know where to break?
How does it know where to break? Yeah.
Yeah, I mean, that is extremely complex. Now it gets even better, because let's say that I have a web server, or let's say I have a application server that's taking data in, and it says a string is a byte array.
Okay.
And it's delimited in some fashion. So what I can do is I can put a particular Unicode character in there. It will break, and the resultant byte coming out after that character is something that null terminates a string, or that changes the context in such a way that, for instance, you get SQL injection because you cleverly crafted a string. And what do they do first? They go, is this string valid? Does it have SQL injection vulnerabilities? Then split it. If they did that, they have a hole in their security now.
Yeah,
because of string processing. And Microsoft's gotten burned by this. Like, a number of big companies got burned by this. It's been a while since this happened.
Yeah.
But, like, that's a real thing. And same thing with Indianness. You can do that with with the encoding, with the Indianness, the way that it's represented. Bad juju, especially on splits. Now, obviously, we talked about casing, right? I can uppercase it, I can lowercase it. Those operations get more complex because of what's in a string. And if the algorithm's wrong, then you could have interesting problems. The next thing is sorting. How do I tell if a string is less than another string? I can't compare byte positions, bear in mind, because the way that people sort in different languages is different, right? And that gets really ugly when you start mixing languages, because the German character that we mentioned earlier, where's that in relation to S in English? Well, the thing looks like a capital B. There should be before. Now, I don't even know where it goes.
Well, I would assume Germany has their own, like, the German language has its own alphabet.
Yeah. It also gets interesting when you do things like kanji, like Chinese characters, Japanese characters, because they have thousands of them. And the sorting system is not going to go with the progression of those bytes.
Yeah.
There's going to be a table that says, hey, this is, here's its value within this sorting page. It's like it's off to the side.
Well, how do they sort over there anyways?
I don't know. And there's Wikipedia articles that get really into it, and I went a little ways and I said, you know what? I don't want to try to describe this on the air, so I'm not.
All right, that's fine. Yeah, that's fair.
That's an exercise for the listener. Now, the next thing that happens with strings is we put data in strings because they're data. So I want to make text human readable, or I want to make text where I can store it in a file that happens to be a text file, like a configuration file or whatever.
Yeah.
That process is called serialization. Put it, one byte after another, and here's your string.
Okay.
That's human readable versus binary serialization, where it's like, here's a byte array, and good luck parsing that. All right. So make it human readable. And then there's deserialization, where I take a string in a file and I turn it into a string object. Because the representation on disk and memory is not the same.
Mm-hmm. Yeah, I understand what you're saying there.
Well, you have problems there, because how am I encoding it? Writing to disk.
There's so many ways to encode.
Right, because I may not, if I'm reading it, I may not be the one writing it. Vice versa as well.
Yeah, that makes sense.
So that's an operation you have to think about in the context of what's going on with text processing around all this. Now, the next thing is searching. And searching, you might go, find me the first occurrence of this sequence of characters. Well, obviously you can do that. You can iterate through, find the individual characters, and go on. But doing it naively on a byte array isn't going to work. Unless you have a naive encoding. Searching gets more fun, though, because most of the time when people search, if it's at all nasty, they'll use what's called a regular expression. And a regular expression it's not really a program, but it's an expression that tells you how to search. And they're very, very painful, as you are aware. Like, if you get a regular expression that says, here's this, it has to pass this to be an email address. That's longer than what's going to fit on your screen.
Yes.
Because it's all the rules and how many characters can be here before this part and how many characters in this segment and, what character set and, there can't be white space. There can't be these other characters. There can't be control characters. There can't be all these things, right? So you got to search that way. Now think about how complex that gets when you have character encodings that are arbitrary and don't necessarily match each other.
Did you know the $sign could be in email? I learned that the other day.
Yeah. And there's thousands of little things. And that's not even a very complex regex.
Yeah.
When you start doing replacements with regex, which is also part of the search function, it gets worse. Because you got to say, okay, I'm going to take a chunk of characters out of here, and this is the group, and here's what I'm replacing it with, which may also be another expression.
Mm-hmm.
So you visualize just how nasty that gets and how quickly it gets that nasty. And bear in mind, we're dealing with character arrays, right? Like, we're not even talking about things like word stemming. Something where I go, okay, how do I stem a word? How do I figure out what the end of something, whether it's an add-on to a word or whether it has semantic value.
Sort of like the word rewatching.
Yeah.
Because the root word is watch.
Yeah. but it isn't about watches.
No. I mean, well, yeah, but watch could mean multiple
But you don't know which
things.
one, right? Like, we're not even getting into the natural language.
Yeah, well, no, that's not even what I was going at. I was just saying the rewatching.
Yeah.
All right? You got the prefix re and the suffix ing. And you got to break that up.
Yeah.
And so, yeah, we're not even getting into that. And
yeah, it's not even the higher level.
Then words having... like the same word having multiple meanings is a completely different...
Yeah, this isn't natural language processing. This is just the idea of what do I have to do to extract data out of a byte array that's supposed to represent a piece of text.
Yes.
So searching is one thing. Another thing is length checking. Of course, we talked about the representation of a string. Like, you got to know which one of those two.
Mm-hmm.
And, I presume that there's other ways to do it as well. Like, if you have a very large string, I would assume that you're not going to go, hey, null terminate this thing. Because then what happens if I load it into memory? Stuff pops, right? Like, I may have to page it.
It's really easy. You just do dot length.
Yeah. Well, your libraries wrap that for you. Your libraries will wrap that for you.
Yeah, I know. I was making a joke.
But you got to realize that there's a lot of complexity under the hood. By the way, for the purposes of optimizing code, you need to be aware of these kind of things. Because if you're doing string manipulation, you can get burned really fast on speed. So here's something nasty that gets done still to this day, and it's the concept of packed bits. And if I have a stream of data that's a string, there may be a section in there that exhibits this. And what basically it is a way to compress numeric data inside of a string. So, for instance, if I say, let's say that if I want to have a string that says BJ's weight is 150 pounds.
Well, that's
not only am I flattering you.
Yes.
But let's back up. Okay, so packed bits. Let's say that I want to say BJ is 35 years old. And I want to say a similar statement for everybody in the U.S. Right, I have 2 bytes in there encoding 3.5 because I'm treating that as a string. What you do? I don't
think everybody in the United States is 35 years old.
No, but
I'm messing with you.
Nobody's 127, right? So I can fit that. Nobody that matters is 127. Like, we can deal with a special case on the side.
Okay.
From a population level, there's 0 to, their age will fit in a byte. So instead of using 2 bytes or more to encode that, I use 1 byte. You have to know the position of that field and then go, oh, hey, in this particular case, it's a number. Now, there's also the packed algorithm, and there's a whole bunch of stuff with how you pack bits and how you can do things like repeating sequences. And it's nasty. But just bear in mind that sometimes a string can also include things that are not a string and still be part of the string.
Okay. Well, you're right. The oldest person in the world currently is 122 years old.
Yeah.
Because I'm nerdy enough to look that up.
Yeah. Well, and the person, they're 122 years old. At some point, there'll be a file with packed bits. And if they make it for another 6 years, they're going to be a baby again because you're going to have an integer overflow.
Wait, take that back. They died in 1997. The oldest living person is only 116.
Yeah. So you got a while.
Yeah.
So more than likely, this will work for the near term, right? This is an algorithm that tends to be used in a lot of really old systems where data storage was really, really expensive because it was cheaper to go, okay, I'm going to process this and get this value out when I need it. But when it's at rest, I don't want it to be taking up disk space. And so you'll still see this on occasion. We see this in our import files. That's just something to be aware of as a operation because sometimes it's not quite an operation. It's a thing of I'm expanding this chunk of text. So, the last piece here.
I'd also like to point out that the 10 oldest living people are all women.
Men die sooner because we want to.
Sorry.
So, now that we've talked about the operations and you see how complex things really are under the hood when you're manipulating text, let's talk about security. Because that's the next little bit of fun.
Oh, joy.
And the biggest one here is bounds checking. In other words, to say, okay, this string is this long, and it's not any longer than this.
Gotcha.
Okay, now where this gets entertaining is situations where you are pushing a string onto a stack frame. So in other words, you understand how a stack works, right? It's like I push values on there and I go, okay, jump down to here and then process and then jump back.
Mm-hmm.
And what does it do when it jumps down? It says, okay, I'm going to pull these things off the stack and do my thing. Well, what happens if I have a string that's longer than the system thinks it is? I can write into that stack frame. And when I come back, the code that processed it is going to pull stuff off of the stack frame at some point or something further up. We'll get a hold of this.
I got you.
And process it. And that could tell it to jump somewhere it's not supposed to go. Like, for instance, to jump to the routine that sets permissions. And, oh, by the way, we push data on there that set the permissions in a certain way. This is how your buffer overflows work. All right, so bounds checking is a big part of this. Another thing that can happen, and this is actually a whole lot more common, is where you say, okay, this string is this long and it's shorter, right?
Okay.
So you read to the end and then you read past the end and you try to access memory that's not owned by your process. And you get an access violation because the operating system wants to keep processes from diddling with each other.
Yeah.
And you break things. I ran into some stuff with this at work, some fairly similar problems with the stack becoming unbalanced because of the way that Delphi allows you to say, okay, these arguments get pushed to CPU registers rather than to the stack. And then I was putting things on the stack. Well, it comes back and it doesn't pop them off in a balanced way. So the stack is out of whack. This kind of stuff can happen. This was really common in Windows, especially between like 1995 and probably 2010. They really went through and they had to clean up a lot of old C code that was going, oh yeah, here's a Pascal string that says it's this length, and we believe them, and it would just pull data. And so it was leading to things where data was getting exposed that wasn't supposed to, or where data was getting written that wasn't supposed to. Now, the next thing to think about is we talked about SQL injection. You have the little Bobby tables problem, right? Which is where I can have data in a string, the string's interpreted by something else, and executed.
Yes.
And obviously, if you do that with a programming language, you can do a lot of damage. Like if somebody passes a string in from a web page and it's built out of all the controls on the page, and you're concatenating all that together, and then you go, okay, now I'm going to do an insert. Now I'm building a SQL query out of this. Well, they could put something malicious in there. You're going to execute that. You can also, break a lot of things if the string has stuff in it that it's not supposed to. Mm-hmm. You'll see this with a lot of people that have single quotes in their names. Like systems will blow up for them all the time. And it's not as common now because everybody's got wrapper libraries, but it used to be really, really bad because that single quote means end this string as far as SQL knows about it. Bear in mind, it's in a larger string that's being sent to SQL Server to be executed. But now what's it expecting after that? Executable code, which it can't parse because it's part of the string, not part of the outer string.
Gotcha. Yeah, I see what you're saying.
So there we are. So that comes into play. Now think about how complex a string actually is and realize how hard this is to actually do. Clean it up. The next thing is encoding errors resulting in security holes. We talked about that earlier, where I can pass a malicious payload and make it look like it's, basically where the encoding is very slightly wrong. Mm-hmm. And I can pass something that gets parsed out in a way that exposes a security hole. And the last one I've got on here as a security issue is something that you saw a lot probably 5 to 10 years ago. And that's where somebody would buy a domain name that looks like a domain name. Like, for instance, if I have a fake search engine and I'm going to call it G00GLE.com. Well, if the characters look close enough, people aren't going to notice the difference, especially when you have overlaps of alphabets or characters that look very similar. And this is a major, this is something they're still trying to kind of fix on the web. And, this is how stuff gets through spam filters as well, is putting those characters in. Because if it's a naive spam filter, it goes, I'm just going to look for this word, and if this word's there, it's spam. Well, that doesn't work. Because it's like leet speak. They can just put it in a different, slightly different thing that it's very obvious what it is, but it's not obvious to a computer.
This is why when you're buying a domain, a lot of times, like a lot of the better services will offer you
misspellings. And they don't tend to go, okay, here's a Unicode character that looks like one of your characters very closely, but isn't it. That's a real legitimate thing.
Yeah.
To have to be concerned about. And think about it in the context of how complicated the rest of this stuff actually is under the hood. And it's a wonder anything works at all.
So that pretty much wraps up what Will put together for us. I know he kind of spent the majority of this episode talking because this was definitely his heavy research on a very interesting topic.
And I didn't go very deep.
Yeah. But before we close everything out, what do you have for us this week for Tricks of the Trade?
Well, this highlights something that I want to point out to a lot of developers. If you're familiar with the term not invented here syndrome, it's the idea of, code from outside isn't as good as what we wrote here, so we're going to write our own. This episode is proof that you don't want to do that. Because you really want somebody that, hey, this is their job, is to get strings correct. Like, you want that guy writing this code. You don't want to do it yourself, because what happens? You get a drop database command executed on your production database, and you get fired. And obviously strings, in this particular case is, that's a very special case of it, but it's still a very painful one. And in general, if you can get a library that does what you want done, it's better to do that, because you would rather wrap that complexity up. Especially when it's stuff like this. Like, it's very easy to look at something and go, oh, it's not that hard to manipulate text. I showed you a bunch of different reasons that actually do make it hard, and I barely scratched the surface. You could end up in a situation where you go through multiple college classes just on string manipulation, and you would not cover everything that's out there. So please, 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 on things that could be difficult, actually look and see if they're difficult, and if they are, get a library that does it. Don't do this stuff yourself. Not invented here syndrome is very bad for you. And that's all I got.
Stand by for Titanfall.
If you have a question or comment for us, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed under Creative Commons. The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up to our email list, be sure and check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with the news about the show. Thanks for listening. See you next time.